Welcome back to the channel. Discussion on AS Physics, October-November 2023, paper 1-1 is what I'm going to do in this video. Let us get started. So the first question, what is the reasonable estimate of the cross-sectional area of the wire in a paper clip? Now the keyword here is cross-sectional area of the wire. You have to imagine that the cross-sectional area of the wire is a circular. Therefore, link to the equation of a circle, which is A equals pi r squared, where A is the cross-sectional area, pi is a constant, r is the radius of the wire. But for your information, there is no apparatus that we can use in the lab to measure the radius of the wire. So the only apparatus that we could use to measure is the diameter of the wire. And we could use micrometer screw gauge to measure the diameter. So I have to link the radius to diameter. So radius is equal to diameter over 2. Sub into the equation and you have pi d squared over 4. Because d over 2, when you square it, you get d squared over 4. Now, things are easier right now. All you need to do is just to estimate the diameter of the wire. So I would say that that's my estimation. I would say that maybe the diameter of a wire is 1 millimeter or 1 times 10 to the power of -3 meter. Sub into the equation, do your calculation, press on the calculator. A equals to pi 1 times 10 to the power of -3, square it, divided by 4. And I got 7.85 times 10 to the power of -7. That is C. You could round off to 8 times 10 to the power of -7 meters squared. Second question, which quantity is not an SI-based unit, standard international based unit? So they are all standard international based quantity. There are all 6 base quantities that you have to memorize in your AS syllabus. The one that is not SI-based quantity is the charge. So A is the answer. Third question, a student determines the acceleration of a free fall by using a small metal ball as shown. When switch S is open, the ball is released from an electromagnet and an electronic timer is started. The ball then falls vertically downwards. The timer stops when the ball hits a trap door. The student measures the distance PQ between electromagnet and the trap door. This distance and the reading on the timer are then used to calculate the acceleration of the free fall. Which statement about errors in the experiment is correct? Now, if you want to think it easy, random error is an error from everywhere, randomly. You don't really know the root of the error because it comes randomly. And systematic error, most of the time, we could relate to the apparatus. So to make my life easier, to get the answer easier, I will look at the systematic error first. So I'll look at D first. D, the systematic error can be reduced by subtracting the diameter of the ball from the distance PQ. Wow, this sounds correct because the students just measure the distance PQ between the electromagnet and the trapdoor and ignore the diameter of the metal ball. Now, okay, I will keep D as one of my choice first, but I'll look at A, B, and C just to eliminate the wrong answer here. I need to choose the correct answer. So C, a systematic error can be reduced by adding the diameter of the ball. Why do we have to add the diameter? Because PQ, the distance PQ already included the diameter of the metal ball. So this is wrong. B, the random error can be reduced. Random error can be reduced by subtracting the diameter of the ball from the distance PQ. To me, random error can only be reduced when you repeat the experiment and you average. So this is wrong. A, the random error can be reduced by adding the diameter. This is totally wrong. So therefore, the answer is D. Question number 4. The diagram shows 2 coplanar forces P and Q drawn to scale. Force R is given by R equals Q minus P. And which diagram represents R? Since they gave you the hint here, drawn to scale, you can always use your ruler to measure distance Q, to measure the distance of force Q, and distance of force P. And always use the easiest way to solve this because this is paper 1, remember? So I'm going to use vector triangle. So vector triangle is the one that I'm using. So I just remember only one rule: tip to tail rule. Firstly, nobody likes the negative sign, so I'm going to eliminate this negative sign. I just put it as R equals Q plus negative P. Is this the same as minus P? I got to change my direction of P since this is about negative P. P is towards right, negative P must be towards left, like that. And I will put Q as my first vector. I'm going to draw Q first. I'm going to draw it here. So Q is here. And all I need to do, the tip of the Q, is continue by the tail of P. And you have to draw to scale as well. You can use your ruler to measure. And the resultant vector will be from the vector that you started to draw first and join to the second vector. So this is what we call our resultant vector. The answer is C. The next question, question number 5. A parachutist falls from a stationary balloon at time t equals 0. Velocity time graph for the parachutist from time t equal to 0 until the time when he is just above the ground is shown. Which graph best shows the variation with time of the acceleration of the parachutist? First of all, when you see this type of graph, and this is a velocity time graph, you have to link to the acceleration. How do we find acceleration from the velocity time graph? Very easy. Acceleration can be calculated from the gradient of the graph. Since there are no values here, I'm not going to do my calculation. It's just to sketch. Now, look at this part of the graph. I'm going to highlight to make you see easier to be seen. I am going to find the gradient of this part, the yellow region. So I am going to plot some of my points here. Since this is a curved graph, to find the gradient, I need to draw the tangent. So by looking at my tangent line, it seems that my tangent lines are decreasing. So it also indicates that the gradient is actually decreasing. It seems that A, B are correct, but not C and D. Because it seems like for C, from the negative value, it increases to 0. So that is wrong because my gradient is decreasing to 0. So I will lock my choices to only A and B. And after that, what happens next is that I'm going to highlight the green region right here. Since this is a horizontal line, the gradient would be equal to 0. P to Q is 0. A and B are still correct. And after that, what happens next is that the gradient is decreasing. And after that, R to S is 0 again. So the gradient, okay, the gradient, it seems to be steeper here, decreases to 0. So it means that the acceleration here is higher because it is steeper as compared to this first tangent line that I drew here. I need to compare the value of my acceleration. So there must be the difference between the two acceleration. One is a negative acceleration due to the tangent lines here are negative and increasing in a negative direction. And my acceleration here will be higher. B will be more accurate. So B is the answer. Question number 6, a projectile is fired from P with velocity V at an angle theta to the horizontal. It lands at Q, a horizontal distance R from P, after time T. The acceleration of the free fall is G, air resistance is negligible. Which equation is correct? Since, okay, I look at all the choices, these are related to sine and cos. I am going to resolve it into two parts. One is vertical, the other one is horizontal. And since R is involved, R is called horizontal distance of the whole trajectory, which is also called range. Range is related to, range or horizontal distance is related to horizontal direction. To make things easier, all you need to do is resolve to horizontal direction. I am going to resolve my V into horizontal direction. This is my V, and this is my theta. I will put this as V horizontal. VH means V horizontal. So right angle triangle, I'm going to use my Pythagoras theorem. Cos theta is equal to V horizontal over V. V horizontal is equal to V cos theta. To find the range, I am going to use one of the kinematics equation, S equals UT plus half GT squared. But I can eliminate this because there is no G acting in horizontal direction. Sx is equal to uxt. I put x represents horizontal direction. Sx I will replace with r, that's the range. Ux is v in horizontal direction. V cos theta times with the time taken, which is t. So Vt cos theta or V cos theta t. The answer is A. The next one, question number 7. A man stands in a lift that is accelerating vertically downwards as shown. Which statement describes the force exerted by the man on the floor? First of all, you have to identify all the forces that are acting on the man. First one is the weight of the man, which is always acting at the center of gravity of the man downwards. And the other one, since the man is standing on the floor of the lift, there will be a normal reaction force between the man and the floor, which is acting outwards. So I am going to use R as a symbol of my normal reaction force between the man and the floor of the lift, and W as the symbol of the weight of the man. So the equation is W minus R equals to MA. This MA represents the net force. Why I need the net force here or the resultant force? Because the question already told us that the man is accelerating downwards. If there is an acceleration, there must be a net force or resultant force, which is equal to MA. And why I use W minus R? It is because the direction is downwards. I will consider downwards as positive direction, and R is acting upwards. So W is equal to mg minus R is equal to ma. R is equal to ma minus mg. So when you deduct something, the value would be smaller. So it is definitely lesser than the weight of the man. Question number 8. A ball of mass 200 grams is thrown vertically or horizontally with a speed of 20 meters per second against a vertical wall. I am going to draw this out so that you can see it easier. This is 200-gram ball thrown horizontally with an initial speed of 20 meters per second. The ball is in contact with the wall for a time of 0.1 second before rebounding back. Wow, this is a keyword. You have to remember this. Rebounding means changing direction. Back to its original path with a speed of 10 meters per second. So the ball rebounds back with the final speed of 10 meters per second. What is the average force exerted by the wall on the ball during the collision? I am going to use Newton's second law, F equals to the rate of change of momentum to deal with this. F, I factorize my M, V minus U over T. Mass is in grams, so I have to change it to kilogram. I just put 200 grams divided by 1,000. That gives me 0.2. Oh, this is rate of change of momentum. Recall, momentum is a vector quantity, therefore the direction is super duper important. I want you to see my diagram. One is towards the wall, the other one is away from the wall. So this clearly represents two different directions. So I will put one positive direction and the other one will take negative direction. The final velocity will take positive direction, which is 10 meters per second. Minus is the difference between the two velocity. negative 20. I put negative 20 because the initial velocity is opposite to the direction of the final velocity. And divided by the time taken, which is 0.1. My answer is 60 Newton exactly. So the answer is B. The next one, in an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. The experiment is repeated 4 times. For each repeat, a change is made to one of the following. First, density of metal of the ball. Second, the height from which the ball is dropped. Third, the density of the ball or the density of the liquid. And fourth, the depth of the liquid. Which two changes separately affect the terminal velocity of the ball in a liquid? Now let me define terminal velocity first. Terminal velocity is the maximum velocity achieved by this metal ball when the weight of the metal ball is being offset by the viscosity of the liquid or the resistance of the liquid. So the terminal velocity definitely will be affected when the density of the liquid is acting. And it also will be affected by the density of the metal because it is related to the volume as well, surface area of the ball. Therefore, the answer is B. Question number 10, two objects move towards each other along the same straight line. After colliding, the two objects stick together and are stationary. This is inelastic collision. Which statement must be correct? A, the total kinetic energy of the two objects does not change during the collision. No, they are changing because they are moving together. Remember, they are moving towards each other. Of course, they are changing. And the total kinetic energy is not conserved because the kinetic energy after the collision is always lesser than the kinetic energy before the collision. B, the total momentum of the two objects before the collision must be equal to 0. This is true. Based on the principle of conservation of momentum, the total momentum before the collision must be equal to the total momentum after the collision. So see what they wrote here, the statement telling you that after the collision, these two objects are stationary. That also means that the total momentum after the collision is equal to 0. It has to be equal to the total momentum before the collision. So B is the answer, but I will prove that C and D are wrong. C, the two objects have equal mass. No, it doesn't mean that they have to have equal masses. This is wrong. D, the two objects have the same speed before the collision. No, it is not always true. So this is not true. B is the answer. Number 11, a minimum torque of 20 Newton meter must be applied to the lid of a jar for it to open. The radius of the lid is 4 cm. What is the minimum force F that must act on each side of the lid in order to open it? Could you see that these two forces are actually coupled? Why they are called coupled? It is because first, they are acting in anti-parallel direction. One is upwards, the other one is downwards. The second reason is because they are of the same magnitude. And the third reason is because they are being separated by a distance. So the torque here, given here, is the top of the couple. It is okay. I just need to find my force first. Torque of a couple is equal to the magnitude of one of the two forces times the perpendicular distance between these two forces, which is 0.08 meter. 20 is equal to force times 0.08. Force is equal to 20 divide 0.08. 20 divide 0.08 and you should get 250 Newton as your answer, which is C. Question number 12, a uniform bar of length L and weight W rests horizontally on two supports, X and Y. Support X exerts a vertical force Rx at a distance of L over 6 from one end of the bar. Support Y exerts a vertical force Ry at the other end of the bar. The bar is in equilibrium. What is the ratio Rx to Ry? First, this is the uniform bar. So the length, total length is L. I would say that, okay, I am not going to write the total length because it looks very messy. But since they told you that this is a uniform bar, the weight must be acting at the center of geometry of this bar. So the distance from the end here to the weight, this is L over 2. And weight to the other end, to the support Y, this is also L over 2. To find the distance here, all I need to do is to find the difference between L over 2 and L over 6. L over 2 minus L over 6, that gives me L over 3. So Rx to the weight, this is L over 3. After that, since they told us that the bar is in equilibrium, so I could use the principle of moment. The total clockwise moment equals total anti-clockwise moment. Rx, I will set my pivot first. My pivot is actually W because I don't want to find the value of W because they don't give me the value of W. Rx towards W, you have to turn that way. When it is turning that way, this is clockwise moment. Ry to W on the other hand, Ry going up, turn to W, it has to turn that way, that is anti-clockwise. After that, just stop in all the necessary information. So to find a moment, it is the force times the perpendicular distance, Rx times the perpendicular distance between Rx and W, which is L over 3, Ry times 3L over 6 or L over 2. So modify the equation, L over 3 Rx is equal to 1 over 2 Ry. Therefore, Rx over Ry is equal to 3 over 2. The answer is 8. The next one, question number 13. A type of firework is made by connecting two rockets facing in opposite directions to a rod as shown. The rod is attached to a frictionless pivot so that the firework can rotate in a vertical plane. The firework has weight W. The pivot exerts a force R on the rod that is equal and opposite to W. Each rocket exerts a force of magnitude F on the rod at a perpendicular distance D from the pivot. The forces exerted by the rockets are always in opposite directions. Air resistance is negligible. Which statement is correct? A, the firework is in equilibrium because the resultant force acting on it is 0. It seems to be correct because the resultant force is actually equal to 0. But there are two conditions for a system to be in equilibrium. What about the total moment? What about the resultant moment? It is not equal to 0. Why? It is because these two forces are acting in the opposite direction and they are perpendicular to each other and they are being separated by a distance. These two forces are coupled and couple will never produce equilibrium. So I say goodbye to A and B. They're not your answer. What about C? The firework is not in equilibrium because the resultant force acting on it is not equal to 0. Resultant force is equal to 0 because F is balanced by F. W is balanced by R. This is also wrong. What about D? The firework is not in equilibrium because the resultant torque acting on it is not 0. That is the exact answer. The answer is D. Question number 14, an object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. What is the ratio of density of oil to density of water? First of all, identify all the forces that are acting on the object. For P, I have weight, which is W. Since the object is immersed in water, there will be upthrust force acting. I would say that my weight minus my upthrust force to give me the reading on the Newton meter. W minus upthrust is equal to P. W, I put P, upthrust as the subject. W minus P is equal to upthrust is equal to rho Vg. Rho W means rho density of the water. And for Q, the reading on Q is W minus the upthrust, because there is also the weight of the object which is acting outwards, and the upthrust force by the oil is equal to Q. W minus Q is equal to rho O. O means the density of the oil, Vg. Now I just take the second equation, divide the first equation, rho oil Vg divided by rho W Vg is equal to W minus Q over W minus P. Now you can cancel the V, you can cancel the G. So this is density of the oil to density of the water. W minus Q over W minus P, the answer is T. The next question, a crate of mass 50 kilogram is pushed a distance of 6 meters along a horizontal surface against a constant resistive force of 70 Newton. The crate moves at a constant speed. This is very important. It is then lifted at a constant speed through a vertical distance of 1.2 meter onto the back of a lorry. What is the total work done in this process? First of all, one is horizontal. So you have to solve for the horizontal force first, and then after that, it is being lifted up to the lorry. That is the vertical direction. So you have to solve it separately, and the total work, you just sum up the two works that you have calculated separately. So I'm going to calculate the work done when the crate 50 kilogram is being pushed by, okay, hold on, I'm going to erase this, pushed by a force, but there is frictional force of 70 Newton or resistive force of 70 Newton acting on it, and the distance is 6 meter. So from here, so the distance is 6 meter. So the work done is equal to the force times the distance moved. Force, I could put 70 Newton. Why? Because the crate moved at constant speed. Constant speed meaning to say that the resultant force is equal to 0. Or in other words, the pushing force is equal to the frictional force or the resistive force times the perpendicular, times the distance, which is 6. I got 420 joules for this one. And after that, the crate is being lifted up. So from the ground, 50 kilogram, lifted it up. Okay, still 50 kilogram. The height is 1.2 meter. For this, I am going to calculate GPE. Hey, energy is equivalent to work because energy is defined as ability to do work. So you could say that energy is equivalent to work. So I'm going to use mgh. 50 times the G is 9.81 and the height is 1.2 and I got 611.76 joules. It doesn't matter how many significant figures that I put in here because I didn't, that is not my final answer just yet. So the total work, I'm going to put in different color. Work total is equal to 420 joules plus 611.76 joule. Use your calculator. You should be getting 1032 joules, round it off to 1000 joules as your answer. So D is the answer. Now, the next one, question number 16. The input power to a television is P in. The useful sound and light power emitted by the television is P out. What is the efficiency of the television? So I'm going to use the symbol of efficiency. This is called eta. So it is actually the output power, useful output power over input power. So the answer is as simple as it. The next one, question number 17. A builder holding a brick of mass 3,000 grams drops the brick on his foot. What is a reasonable estimate of the changing gravitational potential energy of the brick? First of all, I need to come up with the equation of gravitational potential energy. So GPE is equal to mgh. I don't have a problem with the mass of the brick because this is 3,000 grams. All I need to do is just to change the kilogram, which is 3 kilogram. I don't have a problem with G. G is 9.81, but I do have a problem with the height. Okay, so I have to make a good reasonable estimation here. So I just imagine a builder, the height of the builder. Can I say that the height of a builder? Okay, I am not good in drawing, so I hope that you can forgive me. So let's say, oh, this is a cap. Okay, safety cap wears by the builder. So I would say that the height of the builder is on the ground. I would say that maybe the height of the builder is, this is the height of a builder, height of a builder. Maybe it's about 180 cm. That is a normal height of a healthy guy, maybe. And when the builder is lifting out the brick, I don't think that the builder will leave out the brick and put on top of his head, right? That is not possible. Maybe it will leave out the brick to half of his height. So I would say that the distance the brick is being lifted up is maybe the height of a brick being lifted up, being lifted, lifted is maybe half of the height of the builder, maybe 90 cm. So I'm going to put 90 cm here, but I'm going to change that cm to meter, which is equal to 0.9 meter. And I got 26.5 joule. I could round it off to 30 joule. So the answer is A. Number 18, an elastic cord of unstretched total length 16 cm and cross-sectional area of 2 times 10 to the power negative 6 meters square is held horizontally by 2 smooth pins, a distance of 8 cm apart. The cord obeys Hooke's law. A load of mass 0.4 kilogram is suspended centrally on the cord. The angle between the two sides of the cord supporting the load is 60 degrees. What is the Young modulus of the cord material? Oh, I got to be frank here. This question is repeated question from the past year. If you have tried this question before, that's good. If you never tried the question before, this question is actually from one of the past year paper, which appeared in May, June 2020. Paper 1-2, question 18 as well. Now, okay, I am going to solve it right now. First of all, I put out all the forces that are acting on the system. I have the cord, then the cord exerts tension. And bear in mind, how do I define the direction of the tension here? Okay, all you need to do is just to remember it easily. Tension is the force by string or elastic cord that is always opposing to the direction of pulling force. Because when you hang the mass, the weight of the mass will pull it downwards. So the tension will act in the opposite direction, which is outwards, to leave out the mass. So I put out all the forces that are acting and I split it into half here because there are two tensions of the elastic cord that pull the mass. They share the force of the mass. So I use this triangle right here. And I use Pythagorean theorem. I use cos 30 is equal to W over T. But the problem is, remember from the first diagram, this is about two tensions here. So there are two tensions shared by the weight. So these are the two tensions shared by the weight. Therefore, I put 2t cos 30 is equal to mg, weight is equal to mg, t is equal to mg divided by 2 cos 30. M is the mass of the object, which is given as 0.4 times 9.8 divided by 2 cos 30. And the tension that I got here is 2.26 Newton. Once I got my tension, things will be easier. I just define my Young modulus first because the question asks us to find the Young modulus, which is defined as stress over strain. Stress is force over area, strain is extension over original length, and the force here I replace with the tension, which is 2.26. The original length of the cord is 0.16. Surface area is given as 2 times 10 to the power negative 6, and the extension is 0.08. And work it out, you got 2.26 times 10 to the power 6 PA, which the answer is C. You could round it off to 2.3 times 10 to the power of 6 Pascal. Question number 19, which force extension graph shows plastic deformation of a sample of material? Plastic deformation means that the sample would never ever return to its original length, original size, or original dimension. It needs to have permanent extension, which the answer is D. Question number 20, two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P. What is the phase difference between two waves at point P? First, before I come up with the equation of the phase difference, I look at my x-axis. This is time. X-axis represents time, so I modified my phase difference ratio. Phi, this is phase difference, over 360 degree is equal to t over period. T means times different. So phase difference over 360 degree, the time difference between these two peaks, this is 1 second, this is 2 seconds. So the time difference is 2 minus 1, so this is 1. And the period, I'm going to use, okay, this one. No, I'm going to use the highlighter here to show you it is easier. Period is one complete oscillation, or time taken for one complete oscillation, which is 8, 1 over 8. All you need to do now is cross multiply. So 360 degree divides 8. You get 45 degrees. B is the answer. The next one, question number 21. Which row is correct for both progressive transverse waves and progressive longitudinal wave? Transverse wave is not about compression and rarefaction. That is longitudinal wave. Longitudinal wave cannot travel in vacuum. Transverse wave, yes, can be polarized. Longitudinal wave contain compressions and rarefaction. That is also true. C, vibrations are perpendicular for transverse wave, yes. And longitudinal wave can be polarized? No, never. D, some can travel in vacuum, which is true. Longitudinal wave, vibration are perpendicular? No, the vibrations are parallel to the direction of the travel of the wave. Therefore, the answer is B. Question number 22, a toy drone emits a sound of constant frequency of 800 Hertz. The speed of the sound in the air is 330 meters per second. The drone moves along a straight path directly towards an observer and then continues in a straight line directly away from the observer. This is definitely Doppler effect. The speed of the drone is constant. What is the velocity of the drone when the velocity of the sound heard by the observer is 850 Hertz. This is observed frequency. So you don't have to memorize the equation of the Doppler effect because it will be given on the second page of your paper. I'm going to write it down first. F naught, meaning to say that this is frequency observed. Fs, frequency of the source. V is the speed of the sound. V plus minus Vs. You know how I come up with my own way to solve this easier, to have an easier way to solve this? I don't really memorize stuff because I know that when the frequency heard is increasing, to get an increased frequency, I need to divide by a smaller number. To divide a smaller number, I need to find the difference, because when you minus something, your number will be smaller. So I am going to make modification to this, V minus Vs. Sub in information given, and the frequency of the source is 800. Speed of the sound in air is 330 over 330 minus Vs. Vs is equal to, Vs means the speed of the drone, which is equals to 19.4 meter per second, or you round it off to 19 meter per second. And the direction of the velocity, of course, towards the observer. Why? Because whenever the drone is towards the observed frequency will increase. The next one, question number 23, which statement about electromagnetic waves in vacuum is correct? So you need to memorize either the frequency or the wavelength of the electromagnetic wave. I will write it down. Radio wave, microwave, infrared, ultraviolet, visible light, ultraviolet, X-rays, and gamma ray. So this is increasing frequency. Let us look at A, infrared, have shorter wavelength. Oh, this is infrared, have a shorter wavelength as compared to visible light. That is not true because when the frequency increases towards right, the wavelength will be increasing towards left. So this is not true. B, microwave has longer wavelength than radio wave. No, radio waves have the longest wavelength. C, ultraviolet waves have higher frequencies than visible light wave. Ultraviolet has higher frequency than visible light. This is true. D, gamma rays have lower frequency. No, gamma rays have the highest frequency. Therefore, the answer is C. Question number 24, vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a cathode ray oscilloscope, CRO. The waveform displayed on the screen of the CRO has an amplitude of 2.6 cm. A metal wire grid that acts as a polarizing filter is now placed between the source and the receiver. The filter is orientated so that the plane of the polarization of the transmitted wave is at an angle of 20 degrees to the vertical. The distance between the source and the receiver is unchanged. The setting on the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? Now, I just write down the equation which link the intensity and the amplitude because I'm going to use the Malus law to solve this. Intensity is directly proportional to amplitude squared. Therefore, intensity is equal to a constant times amplitude squared. Since the intensity, by Malus law, intensity is equal to I naught cos square theta, I am going to replace this intensity with the amplitude because that's the only information that I have. I have amplitude square here is equal to initial amplitude square, cos square theta. Amplitude square is equal to 2.6 square, cos square, because I'm not going to change that cm to meter because all the choices are in cm, cos square 20. And when you work it out, make sure that you square root it, you will get A is equal to 2.4 cm, which is D. The next one, in an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. Which statement about the experiment is correct? A, at certain times, the string between two nodes is horizontal with all points having zero displacement. Sounds correct to me, but I'll leave it first. Look at B. Each point on the string between two antinodes has an oscillation of the same amplitude. Now, let me draw my stationary wave. This is my stationary wave. Oops. Okay, let us erase a little bit here. Okay, this is my stationary wave. This is what we call antinode. Each point on the string between two antinodes here. Could you see that between these two antinodes, all the amplitudes are different? So they don't have the same amplitude. This is wrong. See, the number of nodes is equal to the number of antinodes. It depends. It is not always equal. This is incorrect. D, two adjacent antinodes oscillate in phase. Now, how do you know whether they are oscillating in phase or out of phase? Very easy. Easy way to look at it is that I redraw my stationary wave. Okay, so between two antinodes, I'm going to focus on two antinodes. Now, this is my first antinode. This is the second antinode. If you like the red wave, you just look at the red wave. If you like the yellow wave, you look at the yellow wave because stationary wave is being formed by the superposition of two opposite waves, right? So I like the red wave. So I'm just going to look at the red wave. So these are two antinodes. You see what happened? Okay, here. I am going to look at my red color wave. I'm going to highlight here. Only this wave. Now, what happens here? How do you get this kind of wave profile is that all the particles will oscillate outwards here. And here, all the particles are oscillating downwards. So two adjacent antinodes, they oscillate in anti-phase because one is outwards, the other one is downwards. So they have a phase difference by 180 degrees. So this is wrong. The answer is A. Question number 26. A musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. The speed of the sound in air in the pipes is 320 meters per second. What is the lowest frequency of sound produced by the pipe of length 10 meter? This is fundamental frequency. I am going to draw the whole thing here. One is note, the other one is anti-note. So therefore, fundamental frequency, the first stationary wave is here, 1/4 lambda. So you have 1/4 lambda, the length of the pipe is given, which is 10 cm. I can relate to that. 1/4 lambda is equal to 10 meter, lambda is equal to 40 meter. V equals to F lambda. So V is 320. F is a frequency that you want to find. This is 40 meter. F is equal to 320 divided 40. Frequency is 8 Hz. So the answer is B. Question number 27. In an experiment, water waves in a ripple tank are incident on a gap as shown. Some diffraction of the water waves is observed. Which change to the experiment would produce or provide a better demonstration of diffraction? So even if you increase the amplitude of the wave, no, it won't give you a better diffraction. B, increase the frequency of the wave. When you increase the frequency of the wave, you are saying that you are decreasing the wavelength of the wave? No, it would not increase the diffraction. Increase the wavelength? Yes, it would. Increase the wave? No. When you decrease the wave, it will increase the diffraction, amount of diffraction. So C is the answer. Question number 28. A light of wavelength lambda is emitted from 2 points, sources R and S, and falls onto a distant screen. At point P on the screen, the light intensity is 0. This is destructive interference. What could explain the 0 intensity at P? For destructive interference, bear in mind the path difference must be equal to n plus 1/2 lambda. N can be starting from 0, 1, 2, 3, etc. So I will say goodbye to B and C because they are not the answer. Therefore, the answer is light from the two sources is emitted in phase and the path difference must be 1/2 lambda. Yes, D is the answer. Now, question number 29, a beam of red light of wavelength 720 nanometer is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed parallel to the grating. The beam of red light is replaced with a beam of electromagnetic radiation of wavelength X, which is incident normally on the same diffraction grating. The third order maximum of the electromagnetic radiation of wavelength X is at the same position on the screen as the second order maximum for the red light. What's wavelength X? Now, since there are two situations here, because the beam of red light is being replaced by the EM radiation of wavelength X, you need to form two equations. I write down the common equation for diffraction grating. D sine theta is equal to m lambda. I'm going to use this. First, for red light, D sine theta second order 2 is equal to 2 to 720 because wavelength of the red light is 720 nanometer. Not going to convert to meter because all the choices are in nanometer. I put this as the first equation. And d sine theta 3 because third order maximum of the electromagnetic radiation. So theta 3 is equal to 3x. I just put x here because I need to find x. Second equation, since they already said that the third order is equal to the second order of the red light, I would say first equation is equal to second equation. So 2 times 720 nanometer is equal to 3x. Work it out. X is equal to 2 times 720 nanometer divided by 3. And you should get 480 nanometer as your answer. A is the answer. Question number 30, the current I in a conductor is given by the equation I is equal to A N V Q. What does the letter N represents in this equation? So the letter N represents the number of charge carriers per unit volume because the N is called number of density, charge density. Density is equal to number over volume. C is the answer. Question number 31. In the circuit shown, the battery has an electromotive force, EMF, of 6 volt and negligible internal resistance. The 3 resistors each have resistance R. Total power dissipated in the resistor network is 24 watt. What is the value of R? First, I'm going to use the equation of power, P equals IV. Find the total current that flows through the circuit first. 24 watt is equal to I times the total EMF, which is 6. I is equal to 4 ampere. So 4 ampere flow out here. And after that, this 4 ampere is going to split to R and to R here. Now, after that, what am I supposed to do is that for R, I am going to find the current that flows through it. I have the potential difference, which is 6. V equals IR. 6 is equal to I times R. The current that flows through this R is 6 over R. And what about the current that flows through 2R? Here, V is equal to IR. Since they are being connected in parallel to the EMF, so the potential difference passing through them will be the same. 6 is equal to I times 2R because the 2 resistors are being connected in series. I is equal to 6 over 2R or 3 over R. Now, since I have the total current, it is very simple. The total current is equal to the current here plus this current here, Kirchhoff first law. So it's equal to I over R plus I over this 2R. 4 is equal to 6 over R plus 3 over R. Make R as the subject. 4 is equal to 9 over R. R is equal to 9 over 4, which is equal to 2.25 ohm. Or you could round it off to 2.3 ohm. D is the answer. Question number 32. Which graph could show how resistance R of the filament lamp varies with the applied potential difference PdV as V is increased from normal operating PD? So when the potential difference increases, the resistance of the filament lamp will increase as well. Remember that. The IV graph is like this for filament lamp. It is increasing like that. So, but for filament lamp, it needs to have its initial resistance. So B is wrong. And D is wrong as well because the resistance decreases. That is no to filament lamp because the resistance will only increase as V is increasing. Therefore, the answer is A. Because C is wrong because resistance is constant all the time. That is not true. Number 33, a piece of conducting putty is in the shape of a cylinder of length 60 mm and diameter 20 mm. The resistance between the two ends of the cylinder is 20 ohm. What is the resistivity of the putty? I am writing down the equation which link resistivity to all the information given here, rho L over A. But the problem is they didn't give me A. So do you still remember for the first question, I always say that the wire, the surface area of the wire is a circular. Therefore, the A you could replace with pi d squared over 4. R equals rho L pi d squared over 4. Now I'm going to sub in whatever information that is given. R is 20. Rho is resistivity, which I'm supposed to find. Length is 60 mm. 60 times 10 to the power negative 3. And pi d is diameter 20 mm, negative 3. But you have to square it divided by 4. So when you work it out, your resistivity should be 0.105 ohm meter. So B is the answer. 34. Which statement about electromotive force, EMF, of a cell is always correct? A. The EMF is the energy converted from electrical to other form of energy? No, this is wrong. This is PD, potential difference. B, the EMF is the energy provided by the cell per unit charge passing through it or through a complete circuit. It sounds correct. C, EMF is the potential difference across internal resistance of the cell. That is not true. D, the EMF is the potential difference across the terminal of the cell. That is called terminal potential difference. This is also not true. B is the answer. Question number 35, Kirchhoff's first law and second laws are the consequence of the conservation of which quantities? Kirchhoff's first law is about charge, conservation of charge. Kirchhoff's second law is about the conservation of energy. So A is the answer. Question number 36, a circuit contains a cell of EMF, electromotive force E, and internal resistance R connected to a resistor of resistance R. Current in the circuit is I. Which equation is correct? So just recall the equation of EMF. EMF is equal to V plus IR, but there's no V here. I have to make modification. E is equal to V using Ohm's law. It is IR plus IR. So E minus IR is equal to IR. A is the answer. Question number 37, a potential divider consists of two resistors of resistances R1 and R2 connected in series across a source of potential difference PD, VE. The PD across R1 is V out, which changes to R1 and R2 will increase the value of V output. Now I write down the equation of potential divider first. V out over V in. This is a common equation. It is R1 over R1 plus R2. I want to increase V out. So I just focus on my V output right here. If I want to increase my V output, I have to increase my R1. So R1 must be double. And if I want to increase my V output, I need to divide by a smaller number. Since R1 has been increased, I want to decrease my R2 so that when I added it, the number will be smaller. And when I divide it, I will get a larger value. So R2 is half. B is the answer. Question number 38, two alpha particles with the same kinetic energy are moving towards and then are deflected by a gold nucleus. Which statement or which diagram could show the paths of the two alpha particles? Remember, alpha particles are positively charged. Gold nucleus is a positively charged, so they will be deflected away. So this one seems that the second alpha particle is going towards the gold nucleus. This is wrong. This seems to be like, how come the alpha particle that's further away from gold nucleus is deflected more than the alpha particle that is closer to gold nucleus? This is wrong too. This one seems to be like the first alpha particle is being pulled towards the gold nucleus. That's wrong. And D, oh, the first alpha particle deflected more because it is closer to the gold nucleus, and the second alpha particle is deflected a bit lesser. Yes, D is the correct answer. Question number 39, which nuclei is formed when 10C undergoes beta plus decay? So all you need to do is just write down the equation. Beta decay, that means 0, beta plus, positive 1, beta plus. So you form 10 minus 0, you get 10. 6 minus positive 1, you get 7. You get 6 minus 1, sorry. 6 minus 1, you get 5. So the answer is C. Last question, a particular hadron is composed of 3 quarks and has 0 charge. What is a possible quark composition of the hadron? So the quark composition that is possible is up, down, and strange, because up is 2 over 3e, down is negative 1 over 3e, and the strange is also negative 1 over 3e. So B is the answer. So thank you very much for watching. I hope this video give you some benefits to get you to be more well prepared for your coming exam. And if you think that the video is useful, please do subscribe to my YouTube channel, or alternatively, I do conduct online classes. If you want to join, do let me know by commenting below. And thank you very much for watching again, and see you in my next video. Bye.